A vast, silent ocean stretching in every direction, an estimated 93 billion light years across and still expanding. Today we're diving into the science behind the universe and how it works, what it's made of, and why it's far stranger than anything we experience on Earth. Escaping Earth. To explore space, we first have to escape Earth's gravity, a force pulling everything toward the center of our planet at 9.8 meters per second squared. A rocket must reach escape velocity 11.2 kilometers per second. That's 40,000 kilometers per hour faster than a speeding bullet. Once we break free, we enter the microgravity, not because there's no gravity, but because we're constantly falling around Earth. Earth from above. From orbit, Earth's atmosphere looks like a thin blue line. It's only about 100 kilometers thick before space begins. This fragile line protects us from radiation, meteors, and extreme temperatures. Without it, Earth would be as lifeless as the Moon. The Moon formed about 4.5 billion years ago, likely from a massive collision between early Earth and a Mars-sized object. It has no atmosphere, no weather, and no temperature swinging from 127 Celsius in sunlight to minus 173 Celsius in darkness. Yet, it stabilizes Earth's tilt, controlling our tides, and may one day most human bases. Tour of the solar system. Our solar system is a cosmic laboratory. Mercury, no atmosphere, daytime temperatures reach 430 Celsius. Venus, thick CO2 atmosphere creates a runaway greenhouse effect, minus 475 Celsius, hotter than Mercury. Mars once had rivers and lakes. Scientists found evidence of ancient waters and possibly conditions of life. Jupiter, a gas giant with a storm, the Great Red Spot, that's been raging for at least 350 years. Saturn rings made of ice and rock, some pieces as small as grain of sand. Uranus and Neptune, ice giants, with suspensionless winds reaching 2,100 kilometers per hour. And beyond them lies the Kuiper Belt, home to Pluto and countless frozen worlds. The Milky Way, our galactic home. Our solar system orbits the center of the Milky Way at 828,000 kilometers per hour. Even at that speed, one full orbit takes 230 million years, a astronomical year. The Milky Way contains 100 to 400 billion stars, and astronauts estimate they are at least 100 billion planets in our galaxy alone. Some may be like Earth, some may host life. Black holes, the strongest objects in space. Black holes from when massive stars collapse under their own gravity. Their density becomes so extreme that space itself carves inwards. The boundary around a black hole is called the event horizon. Cross it, and not even light can escape. At the center lies a single crucial point where one current physical breaks down. We don't fully understand what happens there, but studying black holes may unlock new laws of the universe. Stars are nuclear reactors. In their cores, hydrogen atoms fuel into helium, releasing energy through nuclear fusion. At the same process we're trying to recreate on Earth. A star like our Sun burns about 100 billion years. Massive stars burn hotter and faster, ending their lives in supernovas. explosions that create heavy elements like iron, gold, and uranium. Everything in your body, every atom heavier than hydrogen, was formed in a star. The expanding universe. In 1928, Edward Hubble discovered that galaxies are moving away from us. The universe is expanding, and the expansion is oscillating. Scientists believe this is caused by dark energy, a mysterious form that makes up 68% of the universe. Other 27% is dark matter, invisible matter that holds galaxies together. Everything we can see, stars, planets, gas, dust, is only 5% of the universe. But we have only explored a tiny fraction of the cosmos. But we have new telescopes, faster spacecrafts, and missions to the moon and Mars. We're entering a new era of discovery. Space isn't just a place we visit, it's our future. And the more we learn, the more we realize how much is still waiting there. The universe is vast and mysterious, and our journey has only just begun. In my next video, I'm going to be diving into where we came from evolving from cavemen to what we are now in the new era of life.